Thanks everyone for coming. I'm Mitch.
And I'm Shen.
We'll be talking about empowering data ownership and operational excellence with Starburst, a data mesh approach. And before we dig into it, we wanted to give a little background on where we work. We work at a company called Assurance IQ. It's an insurtech company, and we offer personalized guidance that makes finding and using insurance easier. It's our mission to help consumers improve and protect their personal and financial well-being, which our colleague Killian did a great presentation about yesterday. Thanks, Killian. And what we do is we interact with many consumers all around the United States. We have many agents distributed across many states, and they help educate our customers about potential plans and help enroll them in those plans. And to do that, we have a lot of technology behind the scenes. We have our distributed call center platform, and we also have these great agents on the platform speaking with customers, learning about their needs. And we have the data science models embedded in many different parts of the life cycle that our team, Killian and Naomi, work on. And as you might imagine, there's lots of data points going to this. It's very disparate, it's very complex, and this is something that we want you all to keep in mind as we discuss some of our learnings about the data mesh and why we chose this architecture and approach to our data. So a little bit about us. I'm Mitch, Senior Engineering Manager, and I have been at the company for about 5.5 years, so I've seen firsthand how the data operations have scaled very significantly. When I first started, there was about 50 data consumers or so, and it's at its peak hit up to about 500 internal users, so about an order of magnitude higher. Behind the scenes there, a team of 50 data and analytics developers working on our platform, adding data, manipulating it, transforming it, making it available. So I focus on high quality and readily available data products through a data mesh approach.
My name's Shen. I'm the principal data engineer at Assurance. I've been here about 5 years. I've been mostly focused on optimizations on our data infrastructure and bringing that up and running to make sure and support all the analytics, machine learning, and Gen AI work that we do here. And I have large expertise throughout the entire data lifecycle.
And this is not our first foray with Starburst. We are continuing our Starburst journey. We've been customers of Starburst for quite a while now and been using Presto and now Trino for quite a while. Back in July of 2021, I presented at the Starburst Data Nova for data scientists, where we shared our real-time use cases using Trino and Tableau to show real-time use cases for monitoring our business intraday. And then last year in February, we had a presentation for observability and its importance, especially as our company has grown significantly. As you can see on the right, the data headcount, lots of different domains, lots of different contributors adding to the platform. We had to get a focus and visibility into what was going on in the platform, which is what led us to data mesh and the topic of today's presentation. So empowering data ownership and operational excellence. We're going to go into a little bit more on the Assurance company history and our data platform, how and why we got to data mesh as our chosen framework and why we felt like it was a good fit for us specifically, and then equipping the organization with the data mesh toolbox to really take advantage of all that it has to offer. So how do we get to data mesh? Well, we surveyed our users in Q4 of 2021, several years ago now, and trust was a major theme in the responses. So as the company grew and scaled very, very significantly in a very short time frame, everybody trying to build and experiment and add new features, try new things, grow the business. And what that resulted in is a lot of difficulty navigating all the expansive data assets that were created and added into the platform, contradictory results, or not knowing what the right answers were. And also, not even knowing who to ask if you had a question about it because of people coming in and out, that institutional knowledge kind of embedded in everybody's heads. And the result was a significant impact to the experience that both internal and external data team members were having. So we clearly needed to take action to help remedy the situation, but the question was how. And that's where the data mesh comes in. This is a decentralized, distributed approach to enterprise data management. It's been a hot topic for several years. We came across it about 2 or 3 years ago. Zhamak Dehghani's seminal work discussing data mesh and how the approach is much better than, for the right situation, much better than having a centralized data team being the experts in all lines of business. This is something that Shen and myself, as the early data team members, certainly experienced firsthand, where we were aggregating, collecting all this data into the central data lake, but also expecting to have all the context around it, which was not feasible for us or our small data team in a company that's growing very rapidly and trying many different things, adding new engineering services, what have you. So we really wanted to uncork this bottleneck and not be those subject matter experts, but rather federate it out to the people that are actually closest to this data. So that's where the data mesh comes in. It's not just architecture or technology or organizational change. It's all of the above. So you move from the centralized team sort of bottleneck to something where you actually have domains that have full ownership of their data. Achieving this requires the ability to access data across all these disparate systems and sources as each domain creates and owns their data. And it's really this holistic concept that sees data as distributed products oriented around domains. So I'm sure many people are familiar, but we're going to do just a quick primer of the 4 tenets. So it's of data mesh and this philosophy and way of thinking. The first is domain-driven data. Second is data as a product. Then self-serve infrastructure and federated computational governance. First one, domain-oriented ownership. As we've already mentioned, it really is changing that mindset away from the central team and instead to empowering people who are closest to data to actually become owners of it and be accountable to it. Flows into the next one, which is treating data as a product. So rather than thinking of it as a byproduct of your operation, you view it as what, as Zhamak described, as a first-class citizen. You treat it like any other software product. It's an asset, it has value. You want to treat it as such. You want to have at least some sort of minimum quality standards around it. In order to build those data products, you would use self-service data infrastructure from a central platform that is sort of the bedrock of all of the data products and ownership. And lastly, you need federated computational governance, which is definitely jargony, but what it means is being able to encode the actual policies that enable and allow people to access data as per their authorization or criteria. So you might imagine if you have sensitive data, it's personal information, and only certain people in the business can access it. How do you ensure that the data product knows who's accessing it and provides them the right level of access as intended? And we're going to go more in depth on all of these, bringing it all together. You can see these 4 tenets intersect in different ways. And we figured, hey, how hard could this be? Of course, it is much more difficult than it looks. It's a continuous journey, but we wanted to share some learnings from it. So how do you actually equip your organization? How do you go from the theory to actual practice? We like to think of it as the 3-legged stool here. It comes down to the people who define their processes and use the platform or the technology to apply those processes. And we're actually going to start with the platform. So Shen, I'm going to hand off to Shen. He'll walk us through it.
Thank you very much, Mitch. We're going to start with the self-service infrastructure. And really, what do people actually want to do in data world, really to transform data, right? So I'll sort of talk through the evolution of our transform layers at Assurance. In 2018, when we really started our data team, we used mostly Spark on EMR for some of the larger transformations of data in our space. And then some Python code on EC2 for like pandas or et cetera, some small transformations here and there, or pulling from the API or et cetera. And as we grew and grew as a business, we really started hitting bottlenecks where like, hey, we can't do that yet because we've got all these other things to do as the engineering team. We've got to make sure we finish all these things. And then like late 2020, we started noticing a lot of Python notebooks being run. And people were like, hey, can we just like get this notebook in? Because like, we need to get this specific business request out real quick, right? And so we had that running on some Databricks notebooks because we were using that for ML at the time. And then we were like thinking, okay, how can we make this better? How can we make this work with the data mesh approach? And we realized that, hey, we can move to something dbt. dbt was the hot thing, but we needed the merge capability. And at that time, Trino didn't have the merge capability, but we were still using this at Trino as our sort of main compute engine. For our BI and dashboarding use cases. So we use dbt Spark for the transforms as we were used to Spark for transformations. But as we moved into dbt Spark and we sort of started trying to federate that out, because our users, like our data scientists, data analysts, and the people in the data org are used to using Trino as our query engine, it introduced a lot of complexity in both how do we test this? How do we go through all these different little hoops that you might need in Spark, like being able to access directly to multiple different catalogs or being able to access directly to different source data types and different source data systems. And so those were all very difficult. So we moved to, once Trino and Starburst introduced merge capability, we really moved on to dbt Trino. And we've been migrating things ever since to that. And really, right now, we still have all of these different workflows in our pipeline, right? And because we grew so quickly, we couldn't actually deprecate all of them immediately. But now that we have all of our ETL on, all of our new ETL and a lot of our old ETL now on Trino, we want to move towards that because with our 5 different systems right now, we have a lot of challenges for data engineering. We have challenges in understanding all 5 of the different explains, logs, etc. There's a lot of different little optimization tweaks that you need to know for each different system. That's very hard to then reference each time something breaks. And that is very challenging for a data engineer. Not just that, we have challenges for data scientists as well, and analysts. Whenever they are looking at the data and the lineage and tracing it between and trying to find discrepancies, right, they get to a point where they can't do anything else. They have to ask someone else who worked on the project before, and then it's like this back and forth. And that cycle time goes from a couple of days to a couple of weeks because maybe someone else is busy with something else that's really urgent. And also, if there is a new dashboard or feature for a model or something, etc., what do they use? What are the tools? What are the best practices? And we have documentations for each, but because we have so many different ones, we can't actually focus on really improving one and making one super amazing for everyone. And so, as we embark in the future, we want to really start consolidating these workflows. We really need to deprecate and kill a lot of our really old infrastructure. And so we've been migrating all of our dbt Spark onto dbt Trino. We're starting to migrate all of the old legacy Spark jobs over because really 90% of those workloads can be done in SQL with Starburst Trino. And really the remaining, less than 10% really, are really complex and custom and they'll never be able to be done by SQL, but also they're really complex and custom even within Spark or something. So those are just ones that the data engineering team will have to always manage, but that 90% can be done with SQL, we want to bring that to SQL so everyone sort of understands that. And really, this really brings that benefit, right? Where for the data scientists and analysts, we really empower them to understand any single transformation that's happening in this pipeline, right? We just need to learn a single language for optimizations. People only need to know how to read that explain plan necessarily if something goes wrong. And as I said, if there's something broken or if there's something that they're not sure about or how is this made, they can go to that dbt model, they can run that query in their own ad hoc sort of JDBC connection to the cluster, and they can inspect everything, every single step of the transform themselves, right? Without needing to ask someone else, they can inspect everything themselves first and understand sort of what's going on. The benefits for a data engineer is really maintenance. Right now, we have to maintain 5 systems. It's really complicated and really challenging, and not everyone has that expertise for each of those systems. As we reduce that and consolidate that, we just have only 2. We really help with that maintenance and optimizations. We found that actually with Trino, compared to some of our Spark jobs, because we know how to optimize that better, and our team's more used to it, we've been able to improve a lot of the performance of the transforms that we've moved over. Sometimes by 3, 4, 5x in time. And for automation, as we start focusing on just 2 main workloads, one is custom, which won't have a lot of automation, and the other is very standardized with dbt. We can really start automating things such as we've already started pushing sort of documentation, descriptions, etc. to our downstream BI tools like Looker or Monte Carlo, etc. We do CI/CD checks to make sure ownership is defined everywhere. And we have a lot of plans more for that to make it simpler. And all those other non-SQL workloads that are more custom, etc., we have the Python, we have the notebooks, and we're working with our Airflow orchestrator to really set up the scheduling to enable that DAG dependency between the SQL models that we're building as well as notebooks and vice versa. So as we evolve our transform layer, by 2025, we expect we only have these 2 workflows. We want to really simplify these workflows to just dbt Trino and notebooks. And we've talked about the transform, but the transform needs to run on something. It needs the infra to run on. So really, infrastructure operations, how hard can it be, guys, right? You got to consider auto scaling, auditing, DNS issues, continuous patching, threat detection, Kubernetes, certificate management, single sign-on ranger, networking, load balancing, secrets management, staging environments. compliance, backups and restore, security, monitoring, cost optimization. Have I mentioned networking yet, guys? Right. Provisioning, documentation, logging and storage, version differences, leaf privileged access, instance performance. Really, actually, the keep the lights on for this work is really high. There's a lot of effort that needs to be taken to actually keep the cluster running, right? And now multiply that by the different use cases you want a cluster for, right? You want one to run your ETL jobs daily, at night to run them really quickly. You want one small, medium one for your hourly and 15-minute sort of dashboards and et cetera. You want one for like really fast BI tools. You want one for really large exploratory BI use cases. You want a small one for like ad hoc queries where people are just like, hey, I want to do a select star, limit one, kind of just see what the data looks like. And you want a large one for like backfills and et cetera that you might need to do. Now multiply that by the number of domains that you have as well. We couldn't do that before. And we're right now moving from Enterprise Starburst to Galaxy because we are a very small data platform team. We only have a couple of individuals in it. And we could not maintain multiple clusters for those use cases. And more our users need that, right? And as we move to Galaxy, it's very easy to set up clusters. We just click a few buttons, we have a new cluster, and it auto-terminates when it's not in use. So it's perfect for things like a daily ETL cluster that's massive, so we can push out all those daily jobs real quick. And so we don't have people in the morning going like, hey, where's my data? It hasn't updated yet, right? And that is very cost-effective as well, in comparison to keeping one large cluster up the entire day. And it's not being used as much. And we also get the latest and greatest always. Version upgrades used to be very time-consuming for us, and they come out honestly too fast for our team to do every single version upgrade. With Galaxy, we always get the latest and greatest, and there's a lot of features that I'm really looking forward to in Galaxy. One of them is subquery caching, where they cache like the joins that happen, and that's going to be amazing, because when we saw the first accelerated clusters, which cached just the table information, we already got a 3 to 4x performance on our BI tool. Dashboarding. Now, if we cache that subquery, we should get another huge benefit because most dashboards are really the same queries or very similar queries run multiple times, and caching that join will really help with that. Blast radius. Big difference once we have multiple clusters is that blast radius. Because, I don't know, anyone else had an issue where like someone's query is running for a very large time and it just like blows the entire cluster up? Yeah, you know what I mean. With separate clusters and separate concerns, we can really limit the blast radius of this individual running like a very large exploratory query versus our sort of like fast dashboards that our sort of like sales agents are using for their day-to-day operations, right? Really, that helps a lot in that. And another thing that we didn't realize until we started on this journey is cost attribution. With a single cluster, it's very difficult to be able to tease apart like, okay, this is how much this dashboard cost, or this is how much this sort of use case costed, and this was how much this use case costed. We should really focus on optimizations on this because this is actually costing us a lot of money. It's hard to sort of tease that apart. We can do it, but it's a lot of work, manual analytics that we have to sort of do. As we go into this multi-cluster world, though, we'll be able to have a cost for each cluster and for each type, and we should be able to make that cost attribution much easier, which makes it easier to make that trade-off as we go forward in deciding between optimizations and new business requests. And now, federated governance. We are currently using RBAC with Ranger, and when we move to Galaxy, we're sort of keeping that policies, but it's a very tedious way of doing federated governance. One of the examples is like, let's say we have 5 roles, we have more than that. We have to restrict a specific column in table A, then we need 5 policies for that. If we want those 5 roles to restrict another specific column in table B, we need another 5 policies for that. Now repeat that equation for every single column you want to restrict. Let's say 10 columns, 50 policies. That's a lot. And not just that, you also need to really know all the roles that exist that need to have this, which is really half the battle. And with ABAC, as we move towards Galaxy and ABAC, we will only need specific tags. And so you tag a column, and you say these roles cannot have access to this PII tag. That's one policy. Now, if I'm the data developer, I just need to know what the actual data classification of my column is tag that as PII, and just be like, okay, I don't really need to know all the policies that exist. I've tagged this as PII. That's all good. So our future plans with this is really to embed ABAC into our DBT YAMLs. Because the DBT YAML will describe each column, et cetera, we can embed that information in and then push that out to Galaxy. And I like to call this policies as code to really help increase our audit and maintainability of our policies and enable that federated governance of the data mesh by that set of tags. So I've talked a lot about the platform, and now I'm going to hand it to Mitch about the people and process.
Thank you, Shen. Yes, Shen has done an amazing job at deploying a lot of this infrastructure that our teams get to take advantage of. But it's not something that happens in isolation. It's definitely a mutual collaborative process, and they don't happen, they're not mutually exclusive. The changes as the data mesh philosophy states, it is not just a technology change, but it is organizational as well. So as the platform is changing and evolving, the people and processes have to adapt with it as well, and I've worked very closely with Shen and all of our data domains to help bring all three of those together as per the stool that supports all of our data operations. And ownership is very critical for this concept, absolutely. So going back to that key component or that key tenet of the data mesh, ownership, a domain is really just a collection of people that are organized around a common business purpose, and the data domains, they're the owning teams. They use the self-serve infra and governance to then create and maintain the data products that everybody is accessing and interchanging with. And for the data products, you want to be able to build them a certain level, certain quality, and there's a helpful acronym called DATSYS that points out some of the key attributes Monica knows from the Starburst blog. Yes, very good content. These are the key attributes that you would want to build your data products with. Now, discoverable, addressable, trustworthy, self-describing, interoperable, and secure. That sounds great, but there's also a lot more to it behind the scenes. So getting into more about managing the ownership and data products, the first thing is that you can't use a self-serve platform. You're not going to have success with it unless you get buy-ins from the domains that are going to be using that platform. So you're going to want them to commit to delivering on the DATSYS principles to uphold the data product quality. But with those principles, you actually want to define what they mean for you and your organization so that you can design processes around it so that those principles can be upheld. And we did a whole talk about this last year at Data Nova 2023, so you can definitely check that out. It is on the Starburst website. And this is a screenshot from that presentation where we talked about changing behavior and data culture, how it really took a collaborative effort to bring folks together in the room, discuss what attributes were important to us, and actually define them. So if we look at one example there, the attribute is documented. The description is that there should be some kind of information regarding data about where it comes from, who produced it, who's accountable to it, how it can be used, etc. So you're going to want to design a process around it. As Shen mentioned, we have CI/CD checks that don't allow you to deploy new data assets unless documentation is detected in something like a DBT YAML. And then we have other processes that kick off that actually distribute that metadata to where it's going to be consumed, whether that's in DBT or Monte Carlo or Looker or anywhere that people interface with data. And for us, and you may be in a similar situation if you're considering data mesh, as we mentioned, the business grew very rapidly, things changed very quickly, and our centralized data team definitely had challenges keeping up, which is why we sort of pivoted to this data mesh approach and reining in those data operations. We deemed it to be necessary, and we didn't really know where to begin unless we had visibility into what had actually been built before, whether it was still being used, and whether it made sense to keep it going forward. So getting visibility into the state of the platform as you begin this journey is very, very critical. Because once you have visibility into it, then you can start bringing folks in together to delineate where the lines of ownership actually are drawn and assign ownership and build processes around it from there. So we strongly believe that you can't manage the domains or data products without having some observability solution in place. You can't manage what you don't measure, as the old saying goes. So the observability tools are essential in today's multi-tech environment. As we've shared, we had many different technological changes throughout the history of the company, whether it's Spark, Pandas, or SQL that has now taken root with DBT. So Monte Carlo has many key building blocks that help us operate the people and processes of the data mesh. It's a key part of the technology stack. And what we can see on the screenshot here is actually we can track from the metadata how the data products are changing over time, which is super helpful for platform developers or admins like Shen and myself to just wrap our arms around it, kind of see how the state of the platform is changing, and then work with the domains, bring this data to to the domain so that they're aware of what they're creating and whether it's still something that should be kept around or should be promoted and circulated around the company. So a tool like Monte Carlo, as we think about those DATSIS principles, having visibility into your data lineage is essential. In this case, you could look up something like a Looker dashboard and see all the components that flow into it. This visibility is really key to help build trust. People know where the data is coming from and how it's being transformed and changed. You also, from the ownership principle, you'd want to group contributors into domains. This is how we do it. We have our domains assigned there. We have descriptions for them. And then we assign or drop the data assets into that domain. This is also where a lot of the documentation can live. You want these data products to be self-describing. You want people to be able to search them and find them. So what we've done, as we've mentioned, is folks don't even have to document this manually in the Monte Carlo tool. They actually do it at source in the transform workflow, that single workflow that Shen was describing. And then we have automation processes, self-serve, that just push the data to where it will be reviewed and will be consumed. And to build trust, of course, you're going to want to write checks for your data. This tool also has really great features for that as well. So a domain owner can go in and write a quality check. I actually think, Killian, this might have been yours that you created for one of the tables that they were creating related to some of the machine learning models that were producing data. And then for more complex or wide-reaching jobs, a data engineering team that's ingesting lots of external data sources that are very complex and have a lot of transformation applied to them, you may want to use something like monitors as code, which allows you to apply the same kind of checks, quality checks, to many different data assets simultaneously based on a common pattern. You also want to be able to group these assets in something that you might call a data product, which is something that you can also do in this tool as well. So you could take something like the executives dashboard and drop that into the data product for like view from the top business monitoring, as our CEO, Allison, likes to describe it. And this tool will also help build trust and make these data products addressable. You can see here that it will actually point out if there are any upstream incidents that may be impacting the quality of that data product. So that helps both the producers and the consumers be aware of the state of the domain and whether they need to go prioritize some work. So those are some of the principles and how you can leverage a self-serve platform to really empower your domains. But we just wanted to chat a little bit in more depth of some applications that we've had in practice where we've had some pretty significant valuable outcomes to share. So incident management, documentation, campaigns, and Gen AI for BI foundations. So the first one is incident management. It's all well and good if domains are owners. You have a domain set up, you know who's a member of that domain, you know what data they own. But if there's issues with the data, it's hard to be accountable for it if you can't take action on it. So that's where the incident management part of our self-serve platform comes in place. You can see in these examples here, we have our observability tool publishing alerts for the domains to then take action on. And you can see the threads where they're communicating, sharing information, and hopefully resolving the issues. You can see that one on the left there was normalized, so that was crisis averted. On the right, we can actually see Killian again. Thank you. He is a member of a domain where there was an issue here, it's a schema change in one of our tables, and you can see that he actually made a code change right there and posted it for everybody to see to help mitigate and solve this issue. And the outcome is that domain-specific routing really improves incident response and resolution times, as opposed to a centralized team that might be inundated with all of the different data changes that are coming in place. You can federate out that ownership and then route any kind of data quality incidents to those owners to take action on. It helps really scale up data quality and build trust across your entire data platform. So this has been very valuable for us. We've been very happy with it. The second second use case where we've had a lot of strong outcomes here is documentation campaign. As our company grew very quickly, lots of different data assets were added as new features were built and new partners were brought on board and new data was ingested into the platform. Documentation was often an afterthought, and it was a really big driver of that poor trust in data quality, or that poor trust that we had detected from our users in our survey. So one of the number one things that they had mentioned was like, hey, where's the documentation for this data? I don't understand how it works. When we had put the data mesh framework and the domain framework in place, it allowed us to get the visibility into things like documentation rates And we could actually share this data with the domains to say, like, hey, did you know that the data assets that comprise your domain have a documentation rate of X? As we all agreed, we think documentation, self-described data products is a principle that we want to uphold. Like, here's how you can take action with this data. So we ran a description rate campaign, a blitz, and you can see that in a matter of weeks, we added over 1,000 descriptions into the data platform, into tools like dbt YAML that gets pushed to the observability tool, gets pushed into Looker. We can now see that many of these domains are actually above 80%, above 85% documentation. And when we actually asked our data users about this initiative, we saw that we improved the survey respondents' trust in data, that specific question that we were asking about. That went up nearly 10%. And there was lots of written feedback thanking the teams for doing the work of documenting this key information. And that flows into the next use case, which is, of course, all the rage. We couldn't do a talk on data mesh without talking about Gen AI, and Rahad did a great talk about this earlier, and Killian chatted about this yesterday, as well as Chad, whose screenshot we have up here on the board. Any company is going to struggle to get the true value of AI if the data infrastructure and the data quality is of questionable setup. So what we're finding is that if you can actually empower the domain owners to use your self-serve platform to help encode their knowledge for the data that they're closest to and are the subject matter experts of, you're going to have a much better opportunity leveraging the new technologies that are out there today. So we strongly believe that it's the people behind those domains that use the self-serve mesh platform that really make this work. So we've covered a lot. We just wanted to recap what we call the data mesh toolbox and sort of key principles to keep in mind. Of course, very important one is establishing the domains. You need to get the buy-in from your groups that this is a new framework, a new way of thinking, a new way of operating that they're going to buy into. What's very helpful to accomplish that is simplifying the transform workflow. If you can give them the tools and give them the technology to be great data stewards, you're going to have a much better chance at getting the value from the data mesh framework. You're going to want solid infrastructure, as Shen pointed out, and being able to provision clusters for specific use cases gets you a lot of value as well by being able to do things like track cost attribution, mitigate the blast radius, and really, I think, measure the true cost of data ownership, or what it really takes to create data, manage it, transform it, and actually provide it, distribute it around your company. It's often much more expensive than meets the eye, as anybody's cloud bill may give a hint to. So some other policies, or some other key attributes here: policies defined as code, as Shen mentioned. You're going to want to define what a data product is and what your requirements will be of your domains. An observability engine to help wrap your arms around the state of the platform on this journey is going to be very critical. That helps you assign data ownership. With the data ownership in place, you can set up the right monitoring and alerting systems to notify owners when data expectations may have been violated. Then you can create really great incident management processes around those alerts. And then you can track metadata and metrics around how well the data mesh framework is working. And the last one here, running mesh campaigns, very critical. You have to evangelize this concept. You really have to meet the domain owners where they are. They have different incentives from, of course, internal and external pressures. So you really need to meet them where they are and help communicate that value, make the technology really simple and easy to use so that they're aware of how they can take advantage of it. So this quick slide here, as we mentioned, the 4 tenets of the data mesh. One thing that Zhamak always stresses, the author of the data mesh sort of framework and philosophy, is that there's no one tool that solves this. It's really a change around how you operate. It's a change in the way that you think, and a change in the way that the technology functions. You can mix and match different tools to provide this experience. What's on the slide here is just our stack and what we found is working for us, but you can mix and match depending on your use case as well. And another thing to really keep in mind is whether the data mesh approach is right for your business. With assurance, the data, it's not that the data is massive in volume and we need really strong infrastructure to actually process it. It's more that the data and the semantics that's all coming in is very complex. So federating this out to domains and empowering them with the toolbox, we found was the right approach for us, but it may be different for your company. So that's something you definitely have to evaluate as well. So we're just going to close out here with expectation versus reality on data mesh. It is a hot topic, and it looks great on the surface. It is, but behind the scenes, there's a lot of hard work. You have to go to the domains, you have to get buy-in, you have to change the way that people operate, change their habits. You have to evaluate different vendors, as we had on the previous slide. It's going to be a mix and match. You're going to have to migrate your old systems and possibly deprecate them or deprecate old data. You're going to have to stitch all the component parts together. You may bring on new tech debt in the process while you're dealing with old tech debt. You have to onboard all the domains so that they're aware and educated about how to use the platform, and then you have to continuously train them as the platform changes. But despite all that, given some of the outcomes that we shared today, better incident management, better trust in our platform, and the foundations for great Gen AI, we think that it's totally worth it and is worth considering for your own business. So with that, we'll close it out. Please get in touch if you want to learn more. We're always ready to chat data, ops, anything else. This is Shen. And also, big congrats to Shen for being our 2024 Data Rebel of the Year.
Yes, big congrats to Shen.
Big congrats. Shen, Starburst Data Rebel of the Year.
Thank you.
Yeah, that's it. So we got a couple minutes left. I don't know, Monica.
Thank you, first of all, for explaining really nice overview of the data mesh at insurance. I was wondering one thing, in theory, as you mentioned in the beginning, that data mesh is so fancy, it's nice to approach. But what was the main challenges during the time that you started to decide, okay, data mesh is the right approach? And then, because when your company grows a lot, and then you have to also maintain, but also face the challenges, because not everyone is ready for the new approach. What was your main challenges, and how did you tackle? Because as a company, in a company that I work on, we're also doing a lot of POCs, and it was really interesting to get your perspective.
Yeah. Sure. I could chat from the people and processes side. Definitely getting the buy-in for it was challenging. As I mentioned, a lot of different incentives, but we found that the way that we kind of got around it was definitely starting small and having a very small specific use case, and finding those early adopters who really gravitated towards the principles. I think Killian was definitely one of them, so thank you, Killian.
Yeah, so we really started with, hey, okay, we think this is going to work. We started with DBT Spark because there was no merge in Trino at the time, and so people had to learn a bit more to sort of get onboarded onto that. And so we started with a specific use case. There was a very valuable business use case that needed to be done, but we in data engineering did not have the capacity to actually work on that. We were too busy with other very valuable stuff. But as we built out that framework, we had both ourselves use it, right? Ourselves as data engineers, as well as a few data scientist leads who were like, hey, we need to get this one done as well, and I'm willing to sort of take some time to really learn and think about it to get this project out. And so we have a few of those. We work together really closely. We just a lot of back and forth, a lot of help with that, finding the little issues, the pain points, et cetera, of the development process, and get that going. Really get that started and going. Obviously, if you can start with a tool that people are more used to in your organization, that'll be best, right? Because we started with the DBT Spark. It was not the best start, but Trino did not have the capability at that point in time. But as we moved to Trino, it's much easier now to onboard a new person on it because they already use that for their ad hoc queries. So when you just need to translate the ad hoc queries, it's like, hey, I've already written basically the CTE I need. Move it to DBT, it's done. Obviously, it's not exactly like that. There's still incrementalization and stuff like that that needs to be done, but it's much simpler than before. So really getting that getting some POC out so that someone can play with it, both yourself, to dog food it really, to build it on, and also one of the sort of other teams that want to do some project, but they just can't right now.
Yeah, and to add to that as well, I think the motivation for someone like Killian, I remember we had this conversation, you would come to me and you had done a little bit of analysis on the team's JIRA tickets and got an actual quantitative value of how much time they were spending on data issues, data quality issues, and not having that sort of ownership structure in place. So if you can work with one of those early adopters to get access to data like that, it really helps communicate what is the true cost of ownership of doing things the way you're doing now, so that you can design experiments or POCs to demonstrate how the value is being added by setting up things like ownership and the alerting incident management to mitigate the tech debt management that other teams have to deal with.
In your last slide, I saw Delta in the tech stack. So what was the motivation to not use Iceberg and use Delta here?
Yes, that is a historical motivation. And sorry, this is the last question because of the time. But so when we started actually moving to Delta and merges, it was roughly 2020-ish timeline. Iceberg didn't really exist at that point. It was just Delta Lake or nothing. It was like we started at Delta Lake 0.4. We started adopting it. Now it's kind of more like everything's using Delta. Moving from Delta to Iceberg is a huge challenge to do that migration. We just did not want to tackle it at the time. Maybe in the future, if there's more differences in features and etc. that we really want. But for now, we don't have the capacity to sort of make that migration.